Hello everyone, today I prepared two different examples for the linear programming model. I'm going to use Excel solver to find the optimal solution for these two examples. So first you have to open an Excel file. So in the Excel file we have to enter some information related to the parameter of the model, and then we can use solver package to find the optimal solution. So as you see in the example file, example 1, we have a maximization problem with the two decision variable and the two different constraints. First, we have to enter the information about the decision variable, objective function, and the constraint, and then we can use Excel solver to find the optimal solution. Okay, so first we have to enter the information related to decision variable so here we have two different decision variable, x1 and x2. Then in the first row we have to also enter some other information that I'm going to explain later why we are going to enter this information. So the first one is, after you enter all decision variables, here we have two, you have to define a value about total, sign, and the right hand side. So information related to the sign and the right hand side is related to the constraint. Then after to enter this information, we have to enter some information about objective function. So after that we are going to define the constraint. As you see in the first example, we have two different constraints, so we need two rows for defining the constraint. So we go to the row 3 and we define the constraint 1 and constraint 2. And at the last we are going to define the value of decision variables. So here in this row, after we use the Excel solver, we are going to find the optimal value of x1 and x2 in this row, so as we define here. So I'm going to use the border to make it more clear for here. After you enter this information, now it's a time to enter the coefficient of the decision variable in the objective function and the constraint. So the coefficient of x1 and x2 in the first row, which is objective function, is 1 and 4. So I'm going to enter 1 here and 4 here. The coefficient of x1 in the first constraint is 1, and in the second constraint is 2, so I'm going to enter 1 and 2. For x2 is 2 and 1. This is 2, and then we have 1 here. Now it's the time to enter some information related to the sign and the right hand side. For the objective function, we don't have any sign, so we just pass it. For the first constraint and the second constraint, as you see, the sign is less than or equal, so I'm going to enter less than or equal and less than or equal here. And the right hand side for the first constraint is 6, for the second constraint is 8. So here we have 6 and 8. Now up to this point we enter all in this information that we need. Now we have to fill the part which is related to the total. The value for total is, we have to use equation. So here, for that reason, because we are going to enter the equation, we have to put the equal sign. Then we are going to write the objective function. So what is the objective function? As you see here, the objective function is 1 multiplied by the x1 and 4 multiplied by x2. The value for x1 and x2 is written in this cell. So I'm going to use the equation here, 1 multiply. So here for equation, instead of multiply, we have to use a star sign. Multiply by the value of x1. Where is the value of x1? In this cell, b6, plus 4, which is c2, multiply by the value for x2, which is here. So when you enter the objective function equation, we have to press enter and go to the first constraint. For the first constraint, we have to do the same way. 1 multiplied by x1 plus 2 multiplied by x2. This is the left hand side of the constraint. So again, we have to use the equal sign. 1, which is b3, multiply, we have to use a star, by the value of x1, which is b6, plus 2 multiply by the value of x2. Then when you enter the complete the equation, you have to press enter. And for the third constraint, same logic. 2, which is b4, multiply by the value of x1, plus 1 multiply by the value of x2, and press enter. Now as you see here, we enter all the information that we need for the finding the optimal solution. After you enter all of this information,